In this video, we're going to be solving applications using the Pythagorean theorem. So let's start off with our first example. Usually with word problems, it might help to underline important information and then sketch out a diagram and try and put that information into your sketch. So we'll practice that. So we know the support cable is 140 feet long. And we know it's anchored to the ground and it's 98 feet from the base or the bottom of the tower. We want to find out what the height of the tower is, and then we want to round that value to the nearest whole foot. So we know our base length. The base, or the distance away from the base of the tower, is 98 feet to the anchor where our support cable is attached. The support cable attaches to the top of the tower, tries to keep it from blowing over in severe winds. And we want to figure out the vertical height of the tower. So sometimes you could draw a more detailed diagram. Sometimes you know what shape you want to be able to fill out. So since we're dealing with the Pythagorean theorem, we're going to try and create right triangles with the data given. So we know we're solving for this leg in our right triangle. We can set it up so that a squared plus b squared equals c squared and substitute those values. Or maybe you're fancy enough to do it so that if you know you're solving for a leg, you're going to jump straight to this formula, which is the square root of the hypotenuse squared minus the leg squared. Either way you do it, after you simplify, hopefully you're trying to square root 9,996, in which case we get a decimal that is somewhat like 99.9 something something something. That's enough of a value to figure out whether we need to round up or keep it the same. So we're rounding to the nearest whole number. So we're going to round up and say that it's approximately 100 feet tall. Let's do another example. So let's underline some important information in this description. I'm going to be walking north 40 yards. I have a friend who's going to be walking east 60 yards, and we're taking off from a single location. And then in feet, so different from the values given, we want to figure out how far apart we are from each other. And we're going to round that answer to the nearest tenth. So if we were to start with a diagram of the description, we're starting from a single location, school, and I'm walking north or up 40 yards, and my friend is walking east or right 60 yards. You could solve this problem using yards and then convert your answer to feet at the end. But sometimes when we go through a long problem and we get an answer, we feel so good about ourselves that we forget that final step of conversion. So it might be better to always convert your values first and solve it using the units that are needed. So if I convert 40 yards to feet, 40 times 3 is 120 feet, and 60 yards becomes 180 feet. There are 3 feet in every yard. And now we have our triangle problem, and we're solving for the hypotenuse, or the distance between these 2 points. So using feet, we could set it up. We know we're solving for the hypotenuse. So if we take the square root of the sum of the squares of our legs, then we can solve. So we're trying to square root 46,800. We get a decimal that is 216.33 something something something, but this is enough to round to the 10th spot. So the 10th spot is that first decimal place. We're going to look to the right. If it's 4 or less, we're going to keep it the same. So in this case, we're going to keep it at 216.3. or 216 3/10 of a foot. Let's do another example. This time we're going to pretend that we are looking at a herd of deer that are migrating through this rectangular area that has these dimensions: 40 yards by 70 yards. We're going to end up breaking up that 70 yards into 2 different values here. Again, we're given dimensions that are in yards, but this question is asking us to convert our answer in feet. It's not saying to round any specific way, so as long as we are close in our answer, we should be okay. So again, the first thing I would do is convert my units to feet, so I don't forget to do that at the end. And if you haven't noticed already, what we're really doing is solving two different right triangles. We have this first right triangle, where the distance here that the deer have traveled is the hypotenuse of that right triangle. And then I have this second right triangle up here, where again, the distance traveled by the deer is another hypotenuse of this right triangle. So because I'm solving for two different c values, I notated that by using C1 and C2, just one way to stay organized in your work. So let's solve for the hypotenuse of this first right triangle. So I'm going to break up that 70 yards into just 20 yards for the first right triangle. And we're solving for the hypotenuse. So we know that if we take the square root of the sum of the squares of the legs, we can solve for that. So if I square root 18,000, I get approximately 134.16. So there's our first distance. So the deer are walking, stopping right here, taking a break, and then changing direction and walking over here. So let's solve for this second length right here. So again, we're solving for the hypotenuse. We could do the exact same process we did up here, but just change the leg values. So we take the square root of 36,900, and we get 192.09 approximately. So that's our second length right there. So if I want the total length that the deer have walked, I'm just going to add these two values together. I'm already in feet, so I don't have to worry about the conversion. And we got our distance as approximately 326.3 feet. So kind of some lazy deer if they're only walking 326 feet. Hopefully that's not a long amount of time that we observed them. All right, one more example. This time we are told that we have 3 coordinates, or 3 points on a coordinate plane. And if we connect those 3 points, we get triangle FGH. We want to figure out what type of triangle this is. So if we could sketch out our triangle and have an idea of what we need in our diagram in order to help us solve this problem, we could grab a coordinate plane and plot these points, or we could just sketch it out. Either way, hopefully you figure out that what we need is the distance between F and G, or the distance between 2 points. We're actually going to do that 3 times to solve for each length of this triangle. So we need the distance between F and H, and we also need the distance between G and H. If we have the 3 lengths of a triangle, we can figure out what type it is using Pythagorean inequalities. So that'll be our last step. First, let's figure out these 3 distances. This first distance between F and G would be our distance formula, the distance between these 2 points. Subtract your x coordinates and square it. Subtract your y coordinates and square it. Add that value, or those 2 values together, and we get the square root of 8. We're going to keep it in this square root form because I know I'm going to use the Pythagorean inequalities, and I'm going to end up squaring these values, which will undo my square root. So turning these into decimal values will actually make it messier and a little less accurate. So now let's find the distance between F and H. So again, we're subtracting our x values and squaring them, subtracting our y values and squaring them. And if I add those 2 values together, I get the square root of 26. One more time, find the distance between G and H. Subtract your x values and square it. Subtract your y values and square it. Add those 2 values together and we get the square root of 18. So now we have our 3 lengths. I need to find my longest length so I can use my Pythagorean inequality. Well, the biggest value is the square root of 26. So I'm going to put that by itself on one side. I'm going to take my other 2 lengths and put them on the other side. We're going to square each of our values just like we do in the Pythagorean theorem. When I square a square root, it undoes it. I'm just left with the number underneath. So how does 18 plus 8 compare to 26? Well, 18 plus 8 is 26. So if a squared plus b squared equals c squared, we know we're dealing with a right triangle.